Hey everyone, welcome to my new channel. And from today, we are starting a brand new series on InterviewBit where we'll try to cover each and every problem which is given on InterviewBit. Okay, so today we'll start with arrays, and the first problem is spiral traversal of a matrix. The problem states that we are given a matrix of size n cross m, right? So n is the number of rows, m is the number of columns. So for here, n would be equal to 3 and m would be equal to 3. So the question basically states that we need to find the spiral order traversal of this matrix, right? Okay, so what does spiral order means? So we'll start from the first cell, which is here, and we'll go from here to here. We'll go from left to right, then we'll go from top to bottom, which is from here to here. Okay, then we'll go from right to left, then we'll go from bottom to up, then the cycle repeats. We'll go from right left to right again. Okay, so the spiral order traversal for this matrix becomes 1 2 3 6 9, then you have 8 7, then you have 4 5. So this is the spiral order traversal for this matrix. Okay, right. Now let's take another example where n, the number of rows, is equals to 3 and m, the number of columns, is equal to 4, right? Okay, so for here, the spiral order traversal becomes something like this. You go from left to right, you go from 1 2 3 4, again like this, then you go from 8 12, then right to left again, bottom to up, and then the cycle repeats. Okay, so the spiral order traversal here becomes 1 2 3 4, then you have 8 12 11 10 9 5 6 and 7. Correct, right? So the one thing which we can notice here is the first step involves moving in a direction which is from left to right. Okay, so the problem can be basically broken down into four different steps. The first step involving left to right traversal. The second step involving top to bottom traversal. Okay. The third step involving right to left. And the fourth step would be involving bottom to top. As we can see here in the example as well, we first moved from left to right. Then we moved from top to bottom. Then we moved from right to left again. Okay. Then we moved from bottom to top. Okay, and for the last cell we moved again from left to right. So this is how you can break down this problem into four simple steps which are their individual traversals. Okay, similarly for this case also the same steps would be followed. We first go from left to right, then we go from top to bottom, then we go from right to left, and then we move from bottom to top. Okay, so this problem basically boils down to four different steps, right? So now let's try to have some sort of an idea like how do we start actually. Okay, so what I can think of is I need a left, right, top, and bottom. So the first thing which comes to my mind is how do I maintain these positions, right? So to maintain left, right, top, and bottom, what I can do is I can use sort of four pointers, right? And each of them would be assigned to their ends. So the top, I can have a top pointer which would be pointing to 0 for now. Okay. Similarly, I can have a left pointer which is also pointing to 0 for now. Then I can have a right pointer which would be pointing to the last column. Okay. The last column is m minus 1. Similarly, I can have a bottom pointer which would be pointing to the last row in the matrix. which is n minus 1. So the idea is, so the first step would involve moving from left to right. So what I can do is I'll just iterate while for I is equals to, we'll start from left. Okay, we'll go till I is less than equal to right, and what we'll do is I plus plus, right? And you can have an answer array which is an empty vector for now, and you'll keep pushing the answer over here, right, in the matrix of, and so this would be the row, and this would be the column. Okay, right. What would be the row here? So the row here would be, as we can see, currently the row here is top, and the column would be I. Similarly, we'll traverse from top to bottom. Okay, and for traversing from top to bottom, we'll do the same steps. Top to bottom, I plus plus. Similarly, what I'll push it into the answer, M of. Here, my column would be right. Okay. Now the third step. Now the third step would involve iterating from right to left. Right. So if I need to go from right to left, I need some sort of this. Okay. And what will push? M of. What would be the row here? The row would be bottom, and the column would be I. Okay. Now coming on to the final step, for I is equals to bottom, and we'll go till left top, answer dot push matrix of I, and here the column would be left. All right, but one thing which we need to notice here is when we traverse from left to right, okay, or when we move from left to right in the zeroth row, then what happens is, when we in the next step, when we traverse from top to bottom, we shift a row. Okay, we shift a row. That means your top would be initially pointing at this, right? So you need to shift your top, you need to increase your top of after every traversal, every this traversal, right? Similarly, when you go from top to bottom, that is 6 to 9 here, okay, you need to shift then and in the next step, when you traverse from right to left, you need to shift your right pointer. You're currently, the right pointer must be pointing here, so you need to shift it to one left of it. So what are you gonna do here is, after every second traversal, you're gonna shift your right pointer to one back. Okay, now in the third step, when we are traversing from right to left, after traversing from 8 to 7, you need to move your bottom again. So bottom would have been pointing to here, so we need to shift the bottom to its one back. So bottom would be equals to bottom minus minus, right? Similarly here, when we are traversing from bottom to top, like here we are traversing from 4, so now we need to move the left pointer to 1 again, so we'll increment the left pointer. That's it. Now one thing to notice here is, until when you are gonna do the traversal, right? So the main condition, where do you stop? So the most important case here is while you need to satisfy both left is less than right and top has to be less than bottom. Until then only you have to traverse the whole matrix and then you need to stop. Okay, is this correct? Is this correct? One thing which we are missing, and it is not very obvious, is that when we do not have a row with ourselves, we do not have a row, that means top has increased and you need to decrease bottom. So you need to take care of a condition where top has to be less than equal to bottom, right? So when you are decreasing bottom, you need to make sure that top is always less than or equal to bottom. Similarly, in the case of left and right, when you increase left, you also always have to make sure that left has to be less than or equal to right. Okay, in both of these cases, you need to add an if condition that if top is less than equal to bottom, then only you will traverse in this conditions. Similarly, if left is less than equal to right, then only you apply this condition. Okay, so this looks like a perfect pseudocode for the solution. So the whole idea was, it was a simple, straightforward, implementation heavy problem. So, but this problem has been asked in a lot of interviews by big companies, right? So it's just an implementation heavy pointers. We just need to maintain 4 pointers and just do what the problem says. Just the main thing to take care of is here is about some basic edge cases, and that's it. Now let's move on to the coding part. All right, now let's code it up real quick. So we are given a matrix A. So the first thing which I'm going to get here is the number of rows. So int is equal to the number of rows, which is equals to the size of the matrix. And the number of columns will be equal to a of 0 dot size. Okay, so now what we want to do is we need to maintain 4 pointers here. So the first would be left, which is 0. Right would be equal to the last row, which is the last column, which is m minus 1, and top would be equals to 0, and bottom would be equals to the last row, which is n minus 1. And when do you want to run this traversal? Until when do you want to run this traversal? So while top is less than equals to bottom and left is less than equal to right, run the traversal. Okay, so the first step is moving from left to right. Okay, so we'll start from left and we'll go until right, I plus plus. Also let's maintain a vector called answer to store the answer, and we'll push back a of, what is my row here? The row would be fixed and it would be equal to the top pointer. The columns would change, and what you want to do here is increment top after each traversal. And the next step, we'll move from top to bottom. I plus plus answer dot pushback a of, here my rows would be changing but my column would be fixed and it would be equal to the right pointer, and I'll decrement right pointer after this. The third step involves going from right to left. I minus minus answer dot pushback a of, here my row would be fixed and it would be equal to the bottom pointer, and my columns would be variable. Okay, and after this traversal I need to decrease my bottom pointer. Now the fourth and the final step, which would involve iterating from the bottom pointer till the top pointer. I minus minus answer dot pushback a of, my row would be changing here, which would be I, and column would be fixed, which is left also. So we'll increase left pointer here. Okay, finally will return our answer. But wait, there is one condition missing here. After every traversal, we need to check whenever we are decreasing the bottom line. We need to check if the top is still less than equal to bottom. So if top still less than equal to bottom, then only we have to do this. So I'll just copy it here, I'll paste it here, done. Similarly, I'll check if left is less than equals to right, then only I'll do this. Copy it here, paste it here, done. Now let's run this. Yeah, so the trivial cases are passed. Now let's submit it. Okay. Yeah, so this looks good, and this is the optimal solution. So the time complexity for this solution is O of n square, and we are not using any external space, so it's going to be O of 1. Okay, so that was it for this video. I'll meet you in the next video of this series. Till then, take care. Okay, chalo, bye.